So hello, everyone. Welcome to Building an Open Source Artificial Pancreas. My name is Sarah Withee. I'm glad you could be here. You're welcome to take screenshots and tweet along or anything like that. This is an open source artificial pancreas. I can try and zoom in. It's got like a little computer board in there. All right. Thank you for coming. I hope you enjoyed that. Have a good day. Okay, I'm kidding. If you're like most of my friends or other people I talk to about this, you're kind of like really confused. You're like, wait a minute, it's not like inside me. It's not squishy. It's not anything like they would really expect an artificial pancreas to look like. And so I'll definitely talk a lot about this in sort of what makes this really an artificial pancreas and not like, pacemakers, which are like actually inside a person. In a little bit. But first, really quickly, my name is Sarah Withee. I like to call myself a polyglot software engineer just because I've worked in like tons of languages and different frameworks and stacks and stuff over the years. You can watch my cat zoom back and forth. I've also tinkered with robotics and hardware things over the years. I was on a robotics team in college. I still love fiddling around with hardware things. I'm a conference speaker when there's generally not a pandemic. I also have mentored an all-girls robotics team and some other robotics teams and other kind of programming groups. I've also taught some classes in the past. But one of the things I don't really talk about too much is that I'm a type 1 diabetic. I didn't talk about it for a long time because I feel like there's this sort of stigma to being a diabetic and, like grandpa that likes to eat too much pie or whatever. So hopefully I can break some of these little stigmas too as I talk about this. But to really understand why one would need an artificial pancreas or what kind of problem it solves, we really need to start with the science. Hopefully everybody likes science. I think it's kind of fun. So to do this, we need to talk about really quickly a rundown of how carbohydrates work. So what you do is when you eat carbohydrates, this also includes sugar things, these carbs turn into glucose and fructose. For this talk, we don't care about fructose. Just kind of put those aside. But your glucose then goes into your bloodstream. Your pancreas sees this rise in the glucose and says, hey, wait a minute, I need to, get to work. It starts making this hormone called insulin, which I'm sure everybody's heard of. Your cells see this insulin and the glucose and kind of like, hey, I need to take this stuff in. So then your cells take it in and use it for energy. It's a fairly simple process in terms of like the complexity of the human body. And it's a pretty reliable system. The only problem is when my slides don't advance like I think they should. Here we go. Okay. So diabetes is basically when that process doesn't work. That's all. And you probably have heard of the two types. The first type being that your body doesn't make insulin. So what happens is your autoimmune disease attacks the cells that make it. You don't make it anymore. Type 2 is your body doesn't use the insulin. So you're making it usually just fine, but your body just isn't absorbing it correctly. Your cells aren't using it for energy. So it just kind of builds up in your system. There's other rare types too. Some people have heard of gestational, which is when a woman's pregnant and her body either doesn't respond to the insulin anymore or just kind of stops making it. I've heard this to be both temporary and permanent in people. There's a friend of mine in Pittsburgh here that I live. She very much became permanently diabetic after her child. There's LEDA, and I'm not going to go into these other types too much, but LEDA is probably what I actually am. I don't have the autoimmune disease, so there's probably something else going on behind the scenes that kind of makes me effectively type 1, but not technically type 1. And then there's these other types as well. Another way to explain it is this comic right here, which I think's pretty funny. Pancreas, what happened to your beta cells? Dorp. Don't you need those to make insulin? Dorp. You are producing insulin, right? Blorp. We have diabetes, don't we? Dorp. Yeah. It's so weird because I like hearing the people laugh in the crowd and I have no clue what's going on the other side of this computer screen. So, but let's dive in a little bit more into diabetes and kind of what sort of we have to do to manage this. So we have to constantly measure this amount of glucose in our blood when we can't regulate it anymore automatically. In the United States, we use what's called milligrams per deciliter. Canada and UK, they use millimoles per liter. The particularly sciencey people will realize these are not compatible systems. And you're right. There's a formula to convert between the two. Typical ranges, because you often hear about diabetics that have to keep their numbers in range. For normal people, or as I like to call you, civilians, before meals, your blood sugar is typically going to be 70 to 100. After you eat, it's going to rise, obviously, until your cells can absorb all that extra. So you might get up to about 140. For diabetics, we have to kind of keep a wider range just because we can't manage it as easily. So my doctor always said keep it between 80 to 150. And then after meals, it could possibly go up to 180. So much wider range for that. Sometimes it just kind of feels a little bit more like this, though. Just kind of like random stabs and just kind of hope it works out for the best. It's a very, it feels like throwing darts sometimes. So what happens when this number goes too high? So what happens if you have too much glucose in your bloodstream? Well, what can start to happen is you have bad circulation problems. You can have blood poisoning. So what happens is when your glucose gets too high, your body starts burning fat. The byproduct of this are called ketones. You may have heard this from people trying to lose a lot of weight. The ketones build up in the body, though, and there's not insulin, and then you end up poisoning your blood, basically. Tiny blood vessels called capillaries, those can clog with like glucose molecules. Organs can slowly fail because of that. So kidneys, fingers, toes, eyes, all of these have those tiny capillaries and bad things can happen. You could land in a diabetic coma. So none of these things are particularly great, which is why you don't want your glucose to go too high. Consequently, you're not advancing again. Bad PowerPoint. If your glucose is too low, what can happen? Well, the most obvious symptom is you start shaking, sweating, get really weak. One friend of mine starts hallucinating a little bit when she does this. So it's not really good. It's basically your body freaking out. Just like, oh my gosh, I don't have enough energy. What do I do? What do I do? Everything just goes crazy. You could pass out if it goes too low. Again, you could have a diabetic coma. Turns out you can have one of these if you go way too high or way too low, or death. These are kind of scary things to talk about. We don't really like talking about these things, and I don't really like dwelling on them. I try to, I'm aware that going low is bad. I try not to think about it, though. There's a problem, though, in that a lot of people aren't told some of these warning signs. I know I landed in the ER, and when they decided they needed to do surgery on me, they did a blood test. And I'm like, well, you're fine, except your blood sugar is 400. I'm like, I don't know what that means. And they're like, you're very diabetic. And then, after the surgery, they came back. There's a diabetic educator, and she was just kind of like, you didn't know all of these symptoms? I'm like, no, I had good excuses why all of these things seem normal to me. So sometimes people just don't know, and that makes it a little bit difficult. Diabetics are sometimes told too little information or just information overload. And these are random booklets I found on the internet. When I left the hospital, they sent me home with at least 30 booklets of different things. And one of the things I want to point out is none of these people look like me. I was diagnosed at 29. And most of these people are at least in their 60s, I would guess. It's just weird. None of these really answered my specific situation. And in fact, they sent me home with the wrong prescription, but that's a story for a different day. So this makes it a little bit difficult. If you're not overwhelmed already, let's dive in a little bit further. If your glucose goes too high, you need to take insulin to bring it back down. We kind of talked about that a little bit. And if your glucose goes too low, then you need to eat carbs and sugar to bring that glucose number back up. We'll talk about a little bit why this is not exactly in a fast or immediate process either. Fixing it. So this is my prescription for the last kind of insulin I was on. Average prescription label from a box of insulin. One of the things you may notice, it says inject up to 120 units, and 1 unit is 1/100th of a milliliter. So inject up to 120 units in your insulin pump daily. And like, that's cool, but they don't actually tell you how much to take. They've just told you don't go over this amount. So diabetes is a very weird thing where you actually have to like calculate your own dosages. Which is fine for me. Like, I'm good with math and technology and stuff, but a lot of people are not really that great at this. So this also makes diabetes hard for some people. Let's talk about those calculations now. So the main one that there is what's called a carb ratio. And that's the amount of carbs that you eat to how much insulin you have to take to counteract that. I've seen ranges typically go from 3 grams per unit to 50 grams per unit. I feel like every time I give this talk, I have to change the slide a little bit because I've heard of some other range that's like outside of these things. I'm about 6 grams per unit right now. So if I ate, 20 grams of carbs, then I would have to take like about 3 units. So carb ratios can vary. They vary from person to person. So you have a different carb ratio than I do. And this would be the point where I would point at the audience and say, you have a different one from you, who has a different one from you. It can vary from different times of the day. I found I need more insulin kind of in the morning than I do in the evening. It can vary under different conditions. We'll get to this in a little bit, but like when I'm sleeping, I tend to need a little bit more than when I'm running around during the day. And it changes over your lifespan too. So the carb ratio I had when I was diagnosed is different than what I had last year. It's different than what I have right now. And as I continue to try and go bicycling and do some other fitness things during this pandemic, I expect this also to continue to change. So not only do you have to know your carb ratio, you have to expect it to possibly evolve over time. So if that's not hard enough already, let's make it a little bit harder. When you eat carbs, they start absorbing in your body within 10 to 20 minutes. But insulin takes usually a little longer. So what's called fast-acting insulin, it really hits strongest about 45 to 60 minutes in. But the whole thing can absorb over 5 to 6 hours. And so rapid insulin, it peaks a little bit faster, about 10 to 30 minutes where it hits its hardest, but also still needs to absorb fully over 5 to 6 hours. So here we go. See, there are 2 different graphs. You can kind of see on the left is the fast and on the right is the rapid. So you can kind of see the blue hits its peak, around that 60-minute mark, and the one on the left hits its peak about 45, but you can both see like they both spike up kind of in that like 30-minute range, but it definitely goes faster for the more acting one. And then the purple is the glucose that's absorbed over time. So you can kind of see it doesn't like absorb all immediately. It's very tapered. So you have to kind of keep that in mind, that stacking insulin, which is where if I take a little bit now and I take a little bit later and I take a little bit later, it's going to skew this graph very dramatically. So they always say, eat, take your insulin, and then just wait for several hours before you give another dose. Speaking of doses, there's 2 main types of doses. So one is the bolus. We've talked about this, which is where you eat some food, you take some insulin for it. But your liver also makes glucose throughout the day as well. So you need that all-day insulin for the natural glucose that's going on in your body. Otherwise, you will just naturally build up. And oh, hello, this is the Theodosius, my co-host. So this will build up in your body even if you don't eat any food. So this is very important that you have to also consider this. If that's not difficult enough, let's keep making it harder. If you're stressed, your body's natural reaction is going to be to produce more glucose. If you're sick, your body's reaction is going to be to produce more glucose. If you exercise, that glucose is going to go down because your cells are using more energy. If you have a little bit to drink, your glucose is going to go up because there's a lot of carbs and alcohol sometimes. If you drink a lot, though, you end up having the opposite effect because your blood sugar, your blood composition, I guess, has changed a bit. So this can end up having the opposite effect. So definitely, I was told by my doctor, definitely try to not drink and be diabetic at the same time, just because you can have some very serious bad side effects from this. And then if it's your fancy lady time of the month, your glucose could go up or down, or just whatever your body feels like at the moment. So, you can start to see the diabetes is getting a lot more complicated as time goes on, but we're not even done yet. You can make it even more difficult because we talked about how if it goes too high, we need to correct that. How do you correct it? Well, you have to use your insulin sensitivity factor, which is, I usually call it a correction ratio. And that's how much milligrams per deciliter to how many units of insulin will bring that back down. This number also varies dramatically. It varies from U to U to U to U. And it varies over time as well. I think mine right now is every 15 milligrams per deciliter high. I need to take 1 unit to bring it down. Diabetes is great because this also means very regularly, because there's so many calculations, you can overdose on your medicine, quite frankly. I really like this graphic because it says trick or treating. I think you mean gathering low blood sugar supplies for the next month. And I like to call the day after Halloween, the day after Christmas, and the day after Easter hypoglycemic substance recovery sales, just because all the chocolate and everything goes on sale. And I usually buy up several of it for health reasons, obviously. That's why everybody buys candy, right? Yeah. All right. We talked about exercise. Exercise can throw off things too. Your exercise consumes glucose and can cause your blood sugar to drop pretty fast. My doctor always said take about half the insulin I would in the meal beforehand. So if I ate 50 grams, I would dose for 25. In this case, this is one example of when I went bicycling. At my lowest, I kind of hit like about 75 milligrams per deciliter. It shot up to about 175 and then came right back down because I ate a whole bunch of food. I didn't take any insulin, and then I just literally burned it all off through exercise. So there's definitely a roller coaster that comes with that. All right. If you haven't heard, there's also a global pandemic. So this is a slide I never really thought I would have to add to my talk. But turns out diabetics are a high-risk group. And why are we a high-risk group? Because bad glucose control means your insulin or your immune system doesn't really work as well. So we are more susceptible to not being able to fight these diseases that well. The other side effect is if you have bad glucose control, you probably have respiratory issues. You probably have a whole bunch of other side-related things that are somewhat related to diabetes, but they just kind of like work together to make the situation more complicated. So if you're not overwhelmed yet, you probably should be, because there's a lot of things that happen in a diabetic that just makes things complicated. And you may be thinking to yourself, oh my gosh, Sarah, you just talked for like over 15 minutes and all this nonsense. Why are you doing all that? This is about an artificial pancreas. Well, because we can use technology to kind of solve this problem. So let's talk about this technology. What's out there right now? What can we do with it? Things like that. What do I have literally on my body right now? These are the two main things. So we have a continuous glucose monitor. You can usually see it on people, like you might see a thing on their arm. I don't have it on my arm. I have it on my stomach right now. But and then an insulin pump. And the older ones they look like a pager, and they have a long tube connected to somewhere. I've seen people do them on their back and on their stomachs, sometimes on their legs. The newer ones are kind of like pods. It's just like the insulin is all contained inside this little box, and this little box just goes on your arm. So it's kind of cool. A continuous glucose monitor. There's a plastic part, and this is like this is one of them. This is the whole injector, though. So it sticks the whole piece of plastic on you, sticks that tiny little needle right there into your skin. And then I have this one. It's a little Bluetooth transmitter. So it reads the value from that sensor and then broadcasts it to a receiver. In this case, I can use my phone to find out what that value is. And it does this every 5 to 15 minutes, depending on what brand you use. Mine is every 5. So I can actually come in here. And on my app, see every 5 minutes is one of those dots. I can see kind of what my blood sugar is. So it's pretty cool. It's very handy because it means I don't have to poke my finger very often. I do it about once a day just to kind of make sure everything's on the same track. But it's a lot more handy. I can see what's going on with my body at any given time. So an insulin pump is also great because before you had to just take an insulin shot all the time after every meal. So you had to kind of constantly like stab yourself with the needle. It's not a whole lot of fun. But this, you just stick it in your skin and then it just will deliver insulin continuously. So then you can pull it out. You can punch in like how many extra units to give you for food. And then it'll just give that to you. It's kind of nice. There's no good place and address. So this is mine. Like I said, it's kind of an older one. It looks like a pager. I'll talk about why I have an older one here in a minute. There's a problem though. And these two things are really great, but they don't talk to each other. They're very independent units that don't interact in any way really. So this is finally where we come to the artificial pancreas. And that takes our body to the modern world, where finally we can kind of make these things talk to each other. So there's a few different types of artificial pancreas systems. The first one's called Open APS. This is pretty much one of the originals. It's the one I run. It's on this Linux-based IoT device. So I can actually log in and use it like a regular Linux system if I want. It has a 915 megahertz transceiver on it. So we need this 915 megahertz transmitter and receiver because it talks to old Medtronic pumps like the one I have and can send it signals on what to do. So I'll talk a little bit about why that's an interesting scenario with only old Medtronic pumps. LipKit is kind of one of the more popular ones now. It's kind of been growing since it's a little bit easier to set up. It also has a transceiver board, but it's not running Linux. It's just kind of a board that just kind of listens to signals and rebroadcasts them from Bluetooth to 915 megahertz. It's only on the iOS system. So you have to have a Mac to compile your own version of this app and then stick it on your iPhone. There's no other way to do this right now. And so some people are kind of daunted by this whole thing. There's tons of directions on how to do this on the internet. So it's a little bit easier that way. I see my slide cut off a little bit, but Android APS is kind of basically the Android version of Open APS. So it's all the same algorithms. They just stuck it in an Android app. They made some modifications to it too, so you can switch between those two algorithms. It used to mostly work on old European pumps, so almost nobody in the US really ran this. But with the Riley Link, which is that the Bluetooth transceiver board from this thing, you can now talk to Medtronic pumps and Omnipods, which are the big insulin pumps that you just stick on your arm, like the whole thing on you. So it's gaining a little bit more popularity in the US now. There's this thing, the Medtronic 670. This is one actually made by a medical company. It's very closed source. It's very proprietary. They don't like talking about this kind of stuff. It's a one-size-fits-all system. So there's no real variables. It's always trying to sort of put everybody in the same bucket and try to solve the problem the same way. So I'll talk a little bit about why that's complicated. The algorithms are also kind of conservative. I've set mine to be very tightly controlled, and this one's just kind of like, yeah, we'll try to keep you under 150, you know. And a lot of people don't like it. The transmitters that come with it aren't really reliable. So I've often heard people that have this just turn the looping off. The Tandem is a newer one. I think they released it since the last time I gave this talk. It's also closed source and proprietary. They don't have their own transmitter. They talk to the Dexcom, which is the one I showed here earlier. A friend of mine has this. She really loves it. I've heard other good things from other people too. So this is one of the more promising closed source ones. And the whole process is often called looping. And the reason it's called that is because you start to see this loop. Your continuous glucose monitor gets your blood glucose value. It sends that to a receiver, so in this case, my phone. My phone then uploads it to another open source project called Night Scout. And Night Scout's running on a free Heroku instance in the cloud. And then this Pancreas device will download this data, kind of see what trends are going on. So how many carbs do I have in me? How much insulin do I have in me? And are the results what's expected? Am I going up when I should be? Am I going down when I should be? If not, adjust how much insulin I should be getting right now. So either through boluses or basals, adjust what my pump does. So now these two things that don't talk to each other can talk to each other. There's a few downsides to any of these four systems I talk about. For a couple of them, it's only been old pumps that can work. So those are the ones that have been reverse engineered, hacked, if you will, to figure out how the protocols work. Some of the newer ones have encryption and people haven't quite broken them yet. Old and out of warranty pumps are now getting super expensive. How often can you hear 10-year-old technology is rising in price? Not super often. And it's true, like you might see these things almost given away in the past, but now you can find them upwards of $400 to $1,200. I mean, it's really wild just seeing people are trying to find these old insulin pumps all over. Newer pumps aren't compatible. Just kind of like I said, there's newer encryption with the communications. People haven't really broken it yet. These systems vastly improve the situation, but they're not perfect. There's still some tinkering. You still kind of have to watch it. You don't have to watch it as much. It kind of runs in the background. It does its own thing. It's pretty handy, and I'm not even worrying about it right now, just because I can give a talk, and it just does its magic in the background. It can try and prevent those low blood sugars, that hypoglycemia, but they can still happen. So it tries to cut off your insulin when it detects you're going to fall too low, but sometimes you still fall too low anyway. Some doctors don't really like these systems. I know my current doctor, which I'm planning to switch, she's very much like, why are you running this thing? No, don't do this. Only do the stuff that, is approved by the FDA or whatever. But a friend of mine has a doctor and he's just like, yeah, you do it. You rock it. You're doing it. Yeah. So that's kind of cool. And then med tech device companies hate it. How much do they hate it? Sometimes they'll get the FDA to issue these warnings that old insulin pumps are, what's the term they use? Cybersecurity risks, which is funny because they don't connect to the internet. But potential cybersecurity risk, you need to get rid of these things as soon as possible. You need to get new insulin pumps, blah, blah, blah. It's totally basically because they hate systems like this. They hate people doing stuff with their old technology and they're not making money from it, basically. So with OpenAPS, Android APS, and Loop, there's a few different algorithms they use. OpenAPS has OREF0, which was the very first algorithm that kind of determined what to do. It adjusts that basal over time, so you can hopefully try to keep you in range. OREF1 does that, plus gives you extra boluses. So if you eat too many carbs and you don't dose enough, it will start to give you more to try and counteract that. Loop will also modify your basal and will give you suggestions on when to bolus and how much to bolus for. There's newer branches that are still kind of in development that can do the automatic bolusing. And then Android APS is basically, like I said earlier, OpenAPS, but there's some adjustments in there. I think they kind of changed the timeframes of some of them. OREF0 is basically these 8 or 9 lines. It's a really simple algorithm, and strangely enough, it works really well. I like its simplicity. I'm not going to go over it, but I like just, based on 30 minutes of what's going on in your body, it can make these predictions, which is kind of cool. Okay, I talked for a really long time. This would be the time where I'd ask the audience if they want to see a live demo and get like a lot of cheers. But kind of a quiet audience because you're all text-based. So let's see where's my window? Ta-da! So this is my pancreas in live real time, give or take 5 minutes. So every 5 minutes, we get one of these data points. Right now, I'm 95. Anybody remember if that's good or bad? 95. Yay. Yep. That's pretty good. That's within the normal civilian values even. So over the last 5 minutes, it went up 6 points. My insulin on board is 3.85 units. Cage, sage, IAGE, and beige are all ages of the cannula, which is the tubing, the sensor, which is the glucose sensor, my insulin, so how much insulin I put into my pump, and the battery in the pump. So I can see I'm probably overdue for changing my tubing, but the other things are pretty good. This is how much basal is going in me right now. So right now it's off, just because it's a little uncertain that I was going to go too high. So I can also look here for breakfast. I had 56 carbs of breakfast sandwiches. I took 10 units for it. So you can kind of see they're fairly close together. It rose a little bit, then the insulin kicked in, so it kind of fell back again. And these are the trends it's predicting. So it's the orange is kind of where it's expecting it to go. The other ones are some other variables. You can kind of see combined together, it produces the orange. So it's looking like I'm going to stay pretty in range given its calculations. I can also look around, like I can look at like the last 24 hours and see data points for all that. You can look how much food I've eaten. But you can also see up here, and this is the basal. This is the amount that I'm given all day long. This dotted line, which may be really hard to see, I can't tell, is my default. So if none of this was working, that's how much insulin I would be given. But the actual graph, is it adjusting every 5 minutes? Like, hey, you need a lot more over here to counteract this, but over here, you might have too much in you. We're going to cut you off to make sure things are fine. So, and then I can also see the status of my pump, so I don't actually have to pull it out to see. I have 100 more units of insulin still in me. The battery is 1.45 volts. It's practically new. And it got last updates 3 minutes ago. So, I can hover over this and see Sarborg, which is the name of my pancreas. It's 77% battery, and then my phone is 89% battery. So this dashboard is really cool. I like it. I have pretty much all of the same information in the app. Excuse me. So I can see my butcher jumped up to 101. That's really shiny. I don't know how to fix that. But I can see like all of my ages, the temporary basals, the data points, the predictions, the orange over here, the basal rates, all that. And then I can like issue different commands and tell it different things over in here. So it's a very cool system. I really like it. Something you can't normally do is what I'm going to SSH into my pancreas, because that's a thing people do, right? While that's connecting, maybe I can like bump up my font a little bit. Let's see, did it work? There we go. Okay, cool. So I'm in Sarborg right now. Sarah, Sarborg, never mind. Let's see. So I can do cool things. So right now, I wrote this little script. It just dumps a text file out. But so it can read that insulin sensitivity factor, which is the ISF, the carb ratio, which is how many grams per unit, and then all of my basals all day long, which is this first column here. And these are the numbers I programmed into my pump that if nothing else works, these are the amounts it should give me. Auto-tune runs every day. So it says, hey, you're set up for 15. I think you should be 14.988, which is close enough for me. You're 6, you should really be about 5.7. And then every hour, like here, it thinks I should have a little more. Are there any less? Yeah, so like this one, About 10 p.m., it thinks I should have a little less than normal. So this is sometimes kind of handy to look at just to see, how close am I on its expected basals and things like that. And it still like auto calculates every 5 minutes. So it doesn't, this is sort of a once a day chart it produces. And I can always like rerun some of this stuff. So I can say, hey, right now, go out to the internet, grab those values from Night Scout and start doing some data crunching. So I can look at every 5 minutes, see what the deviation from what's expected is. And then say, this is the basal rate at the time. I need to adjust these. And then here in a couple minutes, it will spit out its adjusted basals at things for me. So it's a cool system. It kind of runs automatically. It's kind of trucking along slow. So I'm going to stop that for the moment. And then there's some other variables in here. I'm not going to dump those out because they have like some passwords and security keys. But there's some variables I can tinker in here. Just tell it what's the maximum amount of insulin to give me at any moment, or what's, how liberal should it try and do these corrections. So there's a lot of safety measures in there too, which I really like. Okay, so at this point, there's a lot of frequently asked questions. Wait a minute, is it really a pancreas if it's not inside of you? Okay, no. They tend to call it a hybrid looping device or an open looping device or a closed looping device, depending on how you use it. It replicates all the functions of your real pancreas, though. So by kind of automating this insulin dosing, depending on what your glucose is, it sort of basically acts like a pancreas. Wait a minute, Sarah, this thing's on the internet and you're trusting it to give you medicine. Is it safe? Yeah, all of this stuff is online. You can read research papers. You can see people have tested it on numerous people. There's at least 2,000 people using this kind of system online right now. It's very reliable. I've read it over before I turned it on to me. And I kind of bumped up the safety levels over time. If it's online, can't you hack it? Okay, sure. But I think the hack ratio to trade-off is not really worth it because typically it's tethered to my phone. So I would have to, figure out what the IP address of my phone is and then hack into that. And then in turn, like get over into the device and then hack through to the Linux and then like run a script and dose me my whole insulin pump. I don't know what you want to do with this, but then kind of like, what's the end result? I don't think anybody's really going to go to this trouble for it. Is it annoying to carry this around? Like, sure. Some people are like, oh my God, I have to have my phone all the time. I really actually do have to have my phone around all the time. If I don't get those glucose readings. So it's a little bit more complicated, but, and then, yeah, this has to stay with me. I think it has to be within like 30 feet of me pretty much at all times. Otherwise the looping doesn't work. So I do have to kind of carry this with me. When I used to go out into the world all the time, I carried this little supply bag around in my backpack just because it had extra pump tubing, extra supplies, extra batteries, extra like tape things to tape it all on me. Usually I carry around one of these just so I can put on another sensor if I need to. It is annoying, but the trade-off I think is really worth it. What if the battery dies? Yep, because your pancreas can die. So if this dies, it goes back to manual mode. So my pump doesn't loop. It just gives its default dose anymore. If the battery on my phone dies, I don't know what my glucose is, so I have to charge that. I always carry a battery pack with me now. But if the device dies, then I just see my glucose values, but it's not looping. There's no automation to it. So I would have to manually control this. Similarly, what if you lose internet access? Kind of the same thing. So if it can't pull down those values from the cloud, it can't do that looping. It doesn't know what's going on with your body. So it can't really make any changes to it. This happens on airplanes because I lose internet access. So for the few hours I'm on a plane, I kind of have to do everything myself, which is fine. Except when I went to London and Oslo last year, the many hour flight meant I had to do a lot of tinkering, especially with airplane food when you don't always know what it's made of. Dirk, I see your question. I'll answer it in a little bit. Why is this not FDA approved? Yeah, so it's not FDA approved. There's nothing to sell because it's all open source. It's not a product people are buying. These are just IoT device things you can just go and buy. They can be used for anything. We just happen to use them for pancreases. And these are just normal prescriptions. Like my doctor had to write a prescription to get these things. So that part's FDA approved. But the system is essentially a self-experiment. So since I'm doing it onto myself, I'm not doing it to other people. I'm not selling this stuff. The FDA doesn't need to regulate it. So it's just not regulated. Why haven't the med tech companies done this? Good point. You figured they would at this point. For the most part, it had been a lot of like, they didn't want to dive into the research. They didn't want to pay for all this stuff. It's too expensive. It's not worth the risk. Having apps that kind of auto-calculate things, it's too complicated. But, you know, turns out when you throw a whole bunch of developers into this and they do a really good job, you know, they are starting to look. And that's kind of where the Medtronic 670 came out. They tried to do their own closed source system with this. Tandem released their thing. There's an organization called Tidepool. They're trying to be this sort of nonprofit bridge between the open source stuff and the closed source pumps and things. So they're still kind of working on this stuff. We'll see how that evolves over time. Okay. So with just my CGM, I had terrible management. You can see all these red numbers. I was very often in the upper 100s, 200s. I wasn't super great at managing this, even with my like science, math, technology background. After I turned on the basal only algorithm, it got pretty good. Had a lot of greens. There's some reds, some highs, some lows, but did pretty well. And you can kind of see here the blues, the insulin changes between like last row is just kind of like, yeah, default values. And here we got all those adjustments. After I turned on the bolusing and basaling, I had days of green numbers. It was great. It was wonderful. This is just one example of 6 days in a row. I had almost entirely good values. It's pretty wonderful. Excuse me. And just zooming in on one of those days, this is a literal 24-hour period where I stayed in between 70 and 120. I have a lot of these now, especially since I switched to the fast-acting insulin. So where's the code? Open APS, instructions, all the scripts, all the how to run it, everything is all on GitHub. Night Scout, which is that Heroku database, is also on GitHub. And then XStrip, which is the phone app that it can look at several different glucose sensors now. That's also online. LoopKit, which was that iOS only one, but is gaining more popularity. Instructions are loopkit.github.io. And then the code for the app is there. Riley Link, which was that Bluetooth board. It's also open source. The guy named it after his diabetic daughter, which I thought was cute. But he pushes all the hardware stuff online. You can also just buy the board. And these are actively maintained projects. They're constantly getting updates by all sorts of people. It's actually really refreshing to see like a really good open source project, not just like get abandoned. So what can the software do? It can help young type 1 children just have fun, run around at recess, not really worry about the diabetic thing, not really worry about going to the nurses often, not really worry about all this stuff, but also let parents kind of keep an eye on their children's blood sugar without needing to, worry as much. It can help older people who can't really manage stuff on their own as easily, and help caretakers kind of watch over them and make sure things are going well. It can help low-income people have cheaper devices, and also help those without insurance use some of this older hardware so you don't have to buy $10,000 to $12,000 new pumps. And I'll admit, I have not wrote any of this stuff so far. But one thing I have thought is installing Linux on a hardware device and flashing it, pulling down things from GitHub, compiling mobile apps. these aren't easy things for non-technical people. They're easy things for me, but they're not easy things for non-technical people. So, one of the things I thought is all of these things can be automated with like a GUI in front. So I've started working with a way to create like a cross-platform desktop app that if you just plug in the device, it can flash all the things or compile the apps and kind of do everything in the background that you would have to do manually from like a command prompt or things like that. My other cat has now jumped up here. Let's see. So let's see. Will this technology evolve to do performance monitoring for athletes? There are some athletes that really want CGMs just because they can do things like that. The main priority is getting them to people that have to have them. So people like me, if I don't know what my blood sugar is, bad things happen. As for systems like this, because those athletes can do their own insulin, they don't need insulin pumps. The system doesn't really work for them. So they can't really do that. They can just only monitor it with a CGM. And then are these systems adapting to biology and environment changes? Not like machine learning, perhaps, but it doesn't know if I'm stressed, but it can see like my amounts are rising when they shouldn't be. So it can dose me more. So there is some adaptation to these algorithms too. So I'm a little bit over time. I'll wrap up here really quickly. One of the things I want to leave you with is what if our software can do things to change lives? And I don't mean just like, like we want to change the world, but like literally change lives. What if our software could have a greater purpose? What if it wasn't all just about delivering better ads or tracking our users doing whatever they're doing or just other weird, creepy things that our tech industry loves to do? What if we could solve problems that big companies have said, we're just not going to work on this? And I kind of love this idea of open source software being this kind of thing that is sort of almost rebellious in a way, but actually for a good cause. So thank you. Slides, videos, all this stuff is over at GeekyGirlSarah.com/pancreas. You're welcome to, I'll hang around on the chat thing too, hop in to answer questions. If you want to say hi, I would normally say you could come up front and hold my pancreas, but that's not a thing you can do right now. But you're welcome to tweet at me on the social media things, ask me questions or just say hi. You're welcome to email me as well. Hopefully Dorpy Pancreas has helped make your day a little bit more amusing. Hopefully you're now thinking like, what does my pancreas actually look like? It does not have eyes and arms and legs, I'll tell you. Hopefully this is interesting. I can try and open this up for questions. But yeah, thank you for coming and hope you have a good rest of the day. I wish I could just see if somebody was like typing anything because it's just empty on my side. I'll leave the slide up for a little bit. But I've had some people kind of want a closer look. So maybe I'll just do that. I'll see if there's any questions. So this Intel Edison, they don't make an Edison anymore, but that's just like a processor slash whole system on one chip. It has a memory and everything in it too. And then the back is the transmitter board. So this antenna is the 900 megahertz antenna that talks to my pump. And then I can connect to it for serial if like SSH isn't working, or I can charge it with both of these. And this battery actually usually lasts almost entirely all day. So the only reason it might not last all day is if it's constantly trying to search for a Wi-Fi signal somewhere, like if I forget to untether my phone or something happens. So then it's just like constantly searching, kills the battery faster. But it usually lasts 18 hours, which is good because I sleep for, a good chunk of the day, like most humans. So it pretty much lasts most of my waking time. It's kind of cool. Thanks, Dirk. I think it's interesting too. I really like talking about this, but also sort of changing people's expectations of, you know, what open source software could also be, but also like, hey, I carry this weird pancreas thing around. Also that you can SSH into it. I think this is, yeah, this is recording. I don't have the foggiest idea how you would access it later, but they are going to be available. I also, over here on my website, you can see past versions of this talk I've given at different places. So even if Pittsburgh TechFest doesn't upload it anywhere, you can still get to like old versions of this. And my slides are on GitHub too, so you can always get the latest version and anything I find that's wrong or just updates like global pandemics. Those slides I'll push up after this. And that you like what I'm doing. I like what I'm doing too. It's been pretty nice to be able to see physically through data how my health is actually dramatically changing. And I forgot who it was. It said, oh, Brian. Brian's a fairly new diabetic. My blood sugar as of last month is 5.4, which if you know anything about A1Cs, 5.5 begins the pre-diabetic level, and then 6.0 is definitely diabetic. And then higher than that is just like really bad glucose control. So I actually now am at normal human levels. Like I had a few friends that are not diabetic that said I had a better A1C than them. So it's been really cool to see my journey through actual data, you know, just see my health get better. And I've been running this for about 2 years. So it was kind of rocky at first, but has evolved over time. How can we create a health tech that will provide leverage to this goal? It's kind of weird because it took several people to see that they could break into this, and somebody happened to just make this database Night Scout program that could track these things, and somebody else just happened to say like, hey, what if we wrote some scripts to kind of automate dosing, and somebody else had already been doing the research onto how could you write algorithms to improve your blood sugar. And so all these pieces just kind of came together to build these systems. As for other kinds of health tech, I don't know. It's kind of, somebody is like, can you create a open source pacemaker? And I'm just like, I don't know that you'd really, I mean, definitely should be, but I don't know that you necessarily want just random devices like this that you can buy off the shelf being a pacemaker. But I definitely think a lot of health tech companies should have more open source, or if not open source, at least explain their algorithms and how their devices work. Because Karen Sandler has a defibrillator in her that she says she was asking her doctor, like, how's this work? You know, what are the algorithms, things like that. And nobody could really provide any good answers. Not her doctor, not the health rep from the company that makes it, not even the company themselves, really. Like I think she said she spent a week running through hurdles trying to figure out more details on her defibrillator and just couldn't find anything about the software and how it works. But she needs it because her heart is not reliable. And so she needs that automatic device to kind of keep it going. And it's definitely kind of freaky to just know we're trusting these companies that don't really publish anything about how this works. So I would love to see more health tech be more open and provide good answers like that. Any other thoughts or questions? Brian wishes his glucose was going to 150. Yeah, you know, kind of like I showed a few slides back, I used to not have really good control. Even, like I said, for knowing the science and the math behind these things, you know, I still had issues with the management of stuff. So even for me, that's pretty good at things, you know, even my doctor told me, like, you're really good at this. You're really good at like guessing your carbs. So keep doing it. But yeah, this still does miraculous wonders way better than I ever could. And I feel like every morning I get woken up to my body reset at like 80. It's great. No matter how terrible I treat my body throughout the day, it just wakes up reset almost. Yeah, and the data and the algorithms. So the Dexcom, which is the stuff, the Bluetooth sensor and everything, they have their own proprietary app, all their stuff stored in their things. So that's why XStrip is kind of valuable, because I get to keep my data. I can share it with the people I want. I can give you the link to my pancreas and you can see it online. But, more importantly, I get to decide what happens with my blood sugar values. I get to keep them. I can trash them. I can do whatever. I'm not reliant on Dexcom. In fact, their servers went down, like 6 months ago for like a day and a half. And people, all sorts of diabetic people that had Dexcoms were freaking the crap out because their systems just became unreliable because of Dexcom. And not saying that Heroku also hasn't went down before, but I think there's some value to saying my data is mine. The values from my body are mine, and I get to do what I want with them. But yeah. Any other thoughts, questions, et cetera, et cetera? I could show off my cats real quick. This is Rorschach. This is Theodosius. They were not on my desk when I started. They climbed onto my desk a little later. Now they're both sleeping. All right, I guess I could stop screen sharing. Thanks for hanging out. Thanks for coming to my talk, and hopefully you all have a good rest of your TechFest. Have a good day.